Hello everyone, this is James Bruce with MakeUseOf.com, and today I'm going to give you an absolute beginner's guide to this, the Arduino. Now, this video is divided into three logical parts. In the first, I'll talk about Arduino as a brand and a little background on what Arduino actually is. In the second part, I'll talk more specifically about the hardware and what it's capable of, as well as talk about shields and different Arduino versions and what you might find in an Arduino starter kit. Then in the third part, we'll take a look at the Arduino software, and I'll try to explain the structure of a program so you can understand some sample code and upload your first application. Let's get started. So Arduino is a brand name. What you see here is the Arduino Uno model, the most widely distributed device. The hardware itself is an open source design, and all of the components are off the shelf. So what this means is that anyone can freely copy the design and sell their own clone or derivative product. In fact, you could put together your own Arduino just by purchasing all of the components individually, like this. In that sense, the Arduino is nothing unique, but it's the combination of the hardware design, the software, and the community around it which makes the Arduino so special. So you might be asking yourself, what is the point of the Arduino? Well, in the past, if you wanted to make something electronic, it would mean getting an electrical engineering degree or buying a kit which limited you to a single project. But with the advent of microcontrollers, making something complex with relatively few lines of computer code has become very easy. The Arduino, therefore, is a rapid prototyping tool. In short, you can make some really awesome things really easily. Okay, let's talk about the hardware for a bit. At the heart of the Arduino Uno is a microcontroller chip here, which is a little like a computer in that you can program it to do different things. There's also a timing crystal, a power regulator, and a USB interface here. Along the sides are a set of input and output pins. On this side are the digital I/O pins. Each of these can be programmed as either an input or an output, and they're digital in the sense that they can be on or off, high or low. Now, a few of these digital I/O pins are special. They're called PWM, and they are indicated with a little wavy line next to the pin number. What this means is that they can act like an analog output by sending pulses, for example, to dim an LED, while the other pins would only turn it on or off at full brightness. On this side are firstly the power connections, from which you can take 3.3 or 5 volts for your components and a ground line. Then you have 5 analog inputs. These are only input, and these would be connected to things like a microphone or a light sensor or a variable resistor. Basically anything which gives a range of outputs would go into here. Now, the layout of these pins is standardized, which means you can buy upgrades of additional functionality called shields, and these shields then slot onto the Arduino. Here's an official Ethernet and SD card shield, for instance, which then gives you network access for your projects and additional storage space. Typically, these shields will use a few of the pins, and then the rest are duplicated on the shield, so again you can stack more shields on top. There's also a small debug LED built into the Arduino on pin 13, which you can use to just test your programs quickly if you don't want to connect an external LED. So as I mentioned, the Arduino is open source, so there's lots of clones or DIY models out there. Functionally speaking, they're pretty much identical, the same components, the same features. The only difference is the price. With the original branded model, you're paying a premium, a charitable donation, if you will, that really goes towards research and outreach programs. Now, you can tell it's an original by this gold-colored component, which was specially commissioned by the Arduino manufacturers, next to the USB socket here. This is a fake Arduino that I bought on eBay. It uses the Arduino Uno trademark, but you can tell it's a fake because the component next to the USB slot is green. These are standard off-the-shelf components, as opposed to the gold one, which was specially commissioned. Now, in my own online Arduino shop, I actually choose to supply a Fundrino clone model, purely because it's 1/3 of the price, which means the starter kits you get from me they're more bang for your buck, basically. We can put in an LED matrix, a LCD screen, lots of little extras that you wouldn't normally get with an original starter kit. Now, there's also different sizes of Arduino. You can get smaller ones or bigger ones. In this case, this is a Funduino Mega. Now this is compatible with the Arduino Uno in the sense that the shields can fit on here, but it also gives you a lot more input and output pins, and there's more memory on the card itself. The best way to get started with Arduino is to get a Arduino starter kit such as this one. Of course, as well as your basic Arduino or a Funduino clone, for instance, you're also going to find a breadboard, either full size such as this one or half size. Now what a breadboard is, basically something that you put components onto like this, and then you connect them together with jumper cables, jumper wires, which you should also get. Makes it very easy to connect things together quickly, put together a circuit. You should also look out for maybe a servo motor, which is a special kind of motor that lets you control exactly where it turns to, rather than just turning it on or off or at a certain speed. You'll probably also get some LEDs and the resistors to go with them. Whenever you use an LED with the Arduino, it pretty much has to have a resistor in series with it. You'll also get some switches, like this, simple push button switches. Now if you're really lucky, you'll also find things like a dot matrix LED display, or even a segmented LED display like this. And perhaps even an LCD screen like this. So you're ready to get programming, and that's awesome. Connect your Arduino through the USB cable and let's get started. I'm going to assume you have a little programming experience here, so you understand terms such as variables and functions, or maybe you call them methods at least. But don't worry if you've never specifically programmed in C language before, neither had I when I started. So this is the Arduino software package. It's also open source and comes with a good mix of example code. Let's go ahead and open up a basic Hello World app called Blink, which will flash the onboard LED on and off. So under examples you'll find basics, Blink. Also down here, if you have any libraries installed, you'll find example programs for working with them. But here we go with basics, Blink. So the structure of an Arduino program is set, and you'll have to follow that if you want to write for the Arduino. First up, at the top of the program, well, you'll probably find some comments first, but then you'll find any variables, constants, and library imports. Libraries being extra bits of functionality that you can add since there's no point reinventing the wheel, things like dealing with time or dates, or libraries for interacting with specific components like a temperature sensor. Constants, like the ones here, are variables which you'll be reusing throughout your program. By defining a constant, you make it easy to later adjust that and make the code more readable. So for instance, here we've defined an integer or a number called LED, and that's number 13. Now that relates to a pin number, so pin 13 is the onboard LED. And what that means is that whenever we tell the Arduino to do something to LED, we're actually just saying do it to pin 13. And if we were to change and put the LED on a different pin, then we'd only need to adjust the bit here that says 13 to 12 or whatever, rather than rewrite the entire program. So obviously in a short demo like this it doesn't matter, but once you get into hundreds of lines of code, it's just good practice to define constants like that. Then we have two functions which every Arduino program must have. The first is setup. Now that runs once only when the Arduino is turned on or reset, so in this function it's normal to instantiate any of the variables to a default value, to do any code that libraries need to start working, or to specify whether a pin is an input or an output pin. Remember, the digital pins can either be input or output, so you need to tell the Arduino which to use it as. In this case we've said pin mode LED output, which should be fairly obvious. It says we want the pin called LED, remember that's pin 13, we want that to be an output pin as opposed to being an input pin. So that's what we've done in the setup routine. Now this is essential, you have to have a setup method, a setup function in every Arduino program, and you also need to have the loop. Now you can always write your own functions of course, but you're certainly not limited to these. These are just two functions that absolutely must be in every Arduino program. So this is loop, which is exactly what it sounds like. The function will loop over and over and over again while your Arduino is on. So After the initial setup function has run once, the loop will keep going, it'll run once, it'll do it again, and then it'll do it again. Ideally, you want to keep this as short and simple as needed, so in this case we're briefly turning on the LED, then we're going to wait. You do this with the delay. Delay is a bit of a hacky way of telling the Arduino to wait because it stops other code from executing, but it'll work for our purposes. So we're telling it to wait for 1,000 milliseconds, and then we're turning it off again, and then we're going to wait for another 1,000 milliseconds, at which point it'll go back to the start and do the whole thing again, thereby blinking the LED. So when you think you're done, it's a good idea to first compile with the tick button up here, and that will identify any possible errors in your code, but then you can upload using the arrow button next to it. Down here you'll see some basic stats on how much of the memory your program is using. Remember, the Arduino only has a specifically limited amount of memory, so if your program is too long it simply won't fit on there, and you'll have to think about upgrading to a different sized Arduino or optimizing your program. So that's the basics of what you need to get started with the Arduino. I hope we can have more video tutorials like this in the future, but for now please check out the rest of my Arduino tutorials on makeusoft.com/tags/Arduino, and don't forget to subscribe to our YouTube channel. Thanks for watching.